This is example 34, and we've got to find the values of theta in this interval, which will solve this equation, which is a compound angle. So we've got theta minus pi by 6 is the angle. So first thing we need to do is look at the range. So although that's the range of values for theta, the range that we've got to look at will have to change because we've got a compound angle. So it's not just theta in there, it's theta minus pi by 6 that we're interested in finding the range for. So we need to look for the range for this one. And what we do is we find the lower value by substituting the lower value of theta into theta here. So we end up with minus pi by 6 is the lower value of the range, the new range, I should say, that we're going to be looking at. So this is our new range. And the upper value is, you take the upper value of theta, which is pi, and then take on the minus pi by 6 there. So if we work that out, then what we end up with is minus 7 pi by 6 is the lower value that we're interested in for our new range. And if we work this part out, then that's going to be 5 pi by 6, and that's the upper value that we're interested in for our new range. So what we then need to do is work out what theta minus pi by 6 is from the calculator. So we can say theta minus pi by 6 is actually the sine minus 1 of minus 1 over root 2. So if we work that out, then our calculator gives us minus pi by 4. So this is our first value that we're going to use to find all the other ones. So what we need to do is we need to draw a sine graph within our new range. So the one we've just worked out here, we need to draw a sine graph within that range. So we've got pi by 2, pi, minus pi by 2, and minus pi. So if I draw a sine graph over that range, then I end up with something like this. And these values that I've got, like the 5 pi by 6, that's really just below pi. So that's there. So we've gone far enough to get that value in, the upper value. And minus 7 pi by 6 is actually just going slightly beyond this minus pi. So we just need to extend the graph just so it's big enough to cover all these values. So then we can look at the value the calculator's given us, and that's minus pi by 4. And we can see that if we projected that down and across, that point there would be minus 1 over root 2. But we do have another value in our range. So we're not interested in any values outside of the range because this graph continues forever. And we would find, yes, there is a solution there, but it's not in our range. So it's outside of, beyond the 5 pi by 6. So we're not interested in this solution here, but we are interested in this one. So this point here, because this graph is symmetrical and repeated, it's actually, if that distance is pi by 4, then it's going to be pi by 4 in from the minus pi. So that means that point is actually minus 3 pi by 4. So they're the only two solutions within the new range that we've found. And so we can now use them to work out what theta is. So what we've got is what theta minus pi by 6 is, but we need to find out what theta is. So for the first value, the minus pi by 4, we can equate theta minus pi by 6 to it. And so if we rearrange that, add pi by 6 to both sides, then what we get is minus pi by 12. And this might look complicated to do, but all you need to do is really, to get the value, it's just minus a quarter plus 1/6 is really the calculation that you're doing to get minus 1/12. And then we know that it's in terms of pi. So that's our first solution. And then the second solution, again, theta minus pi by 6. This time we equate it to minus 3 pi by 4. Add pi by 6 to both sides. So theta is equal to minus 3 pi by 4 plus pi by 6. And so that actually gives us minus 7 pi by 12. And so they are our two solutions, minus pi by 12 and minus 7 pi by 12.